In this lesson, we're going to do perimeters of circle arcs. So we're talking about circles that are not whole. So these two examples are really good ones. We have that basic circle shape, but we have chunks missing. All right, so this is our main circle, and our two important measurements here are our radius and our diameter. Remembering that our diameter is 2 times the radius. And this is our main formula if we have an entire circle ready to go. But we don't have an entire circle. We need to think of a few things. Number one, we've got this big circle arc here. I'm going to call this one L, the length of the arc. We've also got these straight edges here as we cut the circle off. And if we compare that to this, we've actually got our diameter length here, okay, from top into the middle and then out to the bottom again. If you have a look at this one, we've got this as our radius from the center and out, and to the center and out again. So we have 2 of these radii, and we know that 2 of the radii equal the diameter. So we've got a diameter measurement here, and we've also got the length of the arc. So there's 2 things we need to think about. If we're doing the perimeter, we have to say the length of the arc plus our diameter. The length of the arc plus our diameter. Okay. Now, the only way we can find how much of this arc is to think about how much of the circle we've got. And the way to think about that is in angles this time. So we have our full circle. It's got 360 degrees in it. But in this case, we've only got a half a circle. And a half of a circle is 180 degrees. So in this case, we need to think about comparing how much of our normal circle we have. All right, so in this case, we have to say theta, which is our angle of how much circle we have, divided by our 360, or how much we should have, and we're going to times that by our normal circle circumference formula, which is pi d, okay, plus our d on the end. So this part here is showing us what percentage of our full circle we actually have. So if we did that, we would have to say we've got 180 degrees out of a total possible 360. We're going to multiply that by our pi times our diameter, which in this case, if we've got 2 times the radius, will give us our diameter. It will be 2 times 3, which is 6. And then we have to add our diameter on again. So we'll just write this here to remind ourselves. 6. All right. 180 divided by 360 in your calculator is actually saying 0.5. So if you type 0.5 times pi times 6 into your calculator, not forgetting the plus 6 on the end, what we'll get here for this bracket is 9.42. We add our 6 on the end as well to cover our diameter. What we are getting is 15.42 centimeters. So when we're doing this half circle, we've got to think of the diameter, plus we've got to think of the length of the arc. Let's do another one just to compare. Okay, so we've got our whole formula once again. We're going to do our perimeter will equal our length of the arc plus our diameter. We know that the length of our arc is going to be how many degrees of the circle we have divided by 360. And it's going to be multiplied by our circumference formula to find if we had the whole circle, how much would we have? And we have to add our diameter on the end, knowing that we've got a radius plus a radius, and that's going to be our diameter. So let's fill in the gaps here. We've got 270 degrees out of a total possible 360. We are timesing that by pi, and we are timesing that by our diameter, which will be 2 times our radius, which will be 10. And adding that diameter on the end again, so adding the 10 in. Alright, if we do this bit on our calculator, we will get 0.75 times pi times 10 plus our 10, and we will get 23.56 plus 10, which is going to be our 33.56, and we are working in centimeters. Okay. So there's quite a lot to these circle arcs. We have to remember to find out how much of our full circle we have, and therefore remind ourselves what our full circle formula for circumference is. And we have to remember to add in that diameter as well on the end.